Sweet. All right. Just present. Let me just quick, since we changed resolution here, make sure I got my screens arranged. This is a NoSQL presentation, so I hope nobody's offended. Awesome. All right. So I'm going to be talking about Gun.js. This is the Gun.js tagline. But before I begin, let me just introduce myself. My name is Spencer. And for anybody I haven't met, greetings. I am a software consultant here. I started in January, and I work on the Deltek Storm project, primarily on the client side. All right. So Gun is a real-time, decentralized, offline-first graph database engine. That is a big mouthful, but we're going to take it up. We're going to break it down into little bitty parts, and we're actually going to do demos of each of those different parts so we can see how they work. Okay. So here's what I'm going to hopefully get covered today. A little introduction. I'm going to talk about what is Gun, why Gun, the problem, context, modern application development that Gun situates itself into. We're going to talk about graphs and graph databases, primarily just to, we're going to talk about graphs, like mathematical concept of graph and that data structure, just so we can talk about how Gun uses that. There are other graph databases as well. You could look up something like Neo4j or ArangoDB if you're curious. We're going to look at how Gun does offline first, how it does decentralized and peer-to-peer database structure. And we're going to look a little bit at how Gun does real-time updates, building up to, I'm going to demo a real-time to-do app that syncs in real time. So that's where we're going. Okay. Just a few kind of preliminary comments. I'm going to assume basic JavaScript knowledge. If you don't know JavaScript at all, I think you'll still be fine. But I'm just assume some basic JavaScript knowledge, and I think it'll make a little more sense if you've had a little bit of experience with JavaScript. Also going to assume some relational database knowledge, something like MySQL or MS SQL, and also document databases like MongoDB. If you don't know anything about document databases, think a database that stores JSON and searches it. Okay? That's the basics. Because you are all really sharp and a keen audience, you're going to have two burning questions, I'm almost certain. Those are going to be security and conflict resolution. And as we go through, I think it'll become clear what I mean by that. And I've got a couple slides at the end to address those concerns. All right. So what is Gun? Gun is an open source JavaScript library. It's available on NPM and GitHub. It's created by this fellow, Mark Nadal. There's his Twitter handle if you want to comment at him. It also has a fairly active community. They work on a platform called Gitter as a chat application. I'm on there a fair bit. And yeah, so it's an open source library that's available for use. Okay. A little bit more, what about Gun? So it's open source, I mentioned that. Contribute, I've been able to make a few contributions this year to the repository, and that's a lot of fun. It's written in JavaScript. The key reason there is that you can run it anywhere. We've got folks running it on Raspberry Pis. There's React Native extensions, so you can run, native applications on iOS and Android. Of course, you can run it in Node, so put it on a server. You can run it in Electron and build desktop apps. So it's designed to be flexible. It's a graph database, which means it has a really flexible data structure. And we're going to compare and contrast a bit of a table, SQL-oriented data structure, and then a graph structure. It's distributed by design. It's meant to run kind of multiple different Gun servers that sync up at a time. That's the kind of one of the core principles of Gun's design, which means it's scalable. It also means it's hard to kind of stamp out the data. You can't just take one database server down and take down your database. It also has real-time updates, so you can sync data in real time between databases. Okay. Why Gun? And if I had one point that I was trying to argue in this presentation, it is that there's a number of challenges facing modern application development that we have solved in a number of ways. We'll talk about some of those and compare with Gun's method. But that Gun represents more or less a paradigm shift, and it's presenting a different way to approach these problems and tries to kind of make it easy to develop applications in the modern ecosphere that we live in. Okay. So there's some kind of paradigm shifty things that we're going to come up against in this. So a couple of those problems are scalability of centralized architecture. I got some slides, we'll dive into that a little bit. Flexibility of data structure. If anybody sat down and really thought through how to design your database for efficient queries and get the kind of max speed out of your tables, and how do you do the joins most efficiently and things like that. And then you get a new requirement and you're like, oh no, I've got to rethink my database structure. Okay? So to provide some flexibility there. Doing real-time updates. Increasingly, our applications need to be real-time. We need real-time data syncing. And then offline functionality. As you all know, most of us are accessing the web on our mobile devices. The number of users on mobile devices climbs and climbs. But the problem endemic to mobile is that connection is not always secure. Because if you're zipping down the metro and you fly into a tunnel, well, all of a sudden you lost your connection. Does that mean that your user has to stop using your app? No. Maybe so, but what if they could just continue to use it offline? Yeah. So those are some of the concerns that Gun is trying to address and do it in kind of a new and different way. And like I said, we've solved all of these problems with a number of different tools and resources, but Gun is providing a new and different way to do that. Oops, skip space. Any questions about kind of introductory comments, the what and the why? No? Awesome. All right, let's dive in. We're going to talk about graphs. And I'm going to talk about graphs, and then we're going to build a graph in Gun. Right? So let's start by comparing relational databases. Let's say you're going to map out a software consulting firm, something like our software consulting firm here at Solution Street. And so here's some tables that you might have. You're going to have your employees or your users table. And it's going to have the different roles there of the folks and their name and their ID number, which corresponds to their row in the table. And then you've got some projects listed out there as well. So now let's say you want to associate an employee to a project. So one approach, we could add in an additional column to the users table here, called project maybe, and we'll put the ID number to the project. Well, that's all fine and dandy until Lucy is actually going to split her time on 2 projects. Okay, well, how are we going to solve this problem? And as Jeff mentioned to me, you all did this in your interview, so you're familiar with this. Well, what are you going to do? Could you add another column? Well, that's great, but what happens when somebody's working on 3 projects? Do you add another? I mean, this is just not going to work. So we all know the answer. You create another table which references the users, references the projects. You create a join query, and you're able to retrieve all of the users' projects. Right? Easy peasy. So that's how you would do relationships in a relational database. So how would we do something like this in a graph? Let's start at the basic building block of a graph, which is a node. You can think of this more or less corresponding to a row in a table. It kind of has that atomic unit of data. So here's a node called Spencer. This would be one node in our employees, in the group of employees. You'll also hear in graph database speak nodes referred to as vertexes. I'm just going to use the word node because it's a little easier. Now let's say we're going to add Spencer to our employees node. Now that employees node, you can see it has 3 keys in there: Spencer, Lucy, and Kevin. These are our 3 employees, and I've got a little arrow symbol. The reason here is because employees doesn't contain all of the information like sub documents in there. It just contains references to other nodes. Okay? That relationship in graph database speak is called an edge. So you can have edges and vertexes. I'm just going to use the language nodes and relationships. Okay. All right. And so you can imagine that there's a number of other nodes here. We've got the Lucy node and the Kevin node and things like that. And if we want to add a new employee, we add their node and then add the relationship in the employees node. So now imagine we're just kind of zooming out from our graph. So we back up a little bit. Maybe our graph looks like this, where we can draw a relationship between a user and the project that they work on. We also have a projects node. And this projects node has references to the various projects that we work on, contains information about their name, any other things like that. So again, zoom out, and maybe here's Solution Street. We've mapped out all of their projects. We've mapped out all of their employees. But we're going to collaborate with another consulting firm in the area. We're going to get one of our employees, one of their employees, and they're going to collaborate together on a shared project. How would we represent something like that? So let's zoom out one more level, and we could just imagine something like this, where there's firm B. Here is the shared project. One of the Solution Street folks is going to work on this. One of their folks is going to work on this. Here's their project node. It's got a relationship to this project. And so you can see how it'd be pretty easy just to kind of extend your graph and add in data, this kind of new set of data. All right. So at this point, we're going to go in and dual purpose here. We're going to learn the Gun API. It's really simple. It only has a few methods. And we're going to build up a graph. So I'm going to run through these methods here. But don't worry if it doesn't make sense, because we're going to go and actually use this on the console and create a graph so you get to see them a whole bunch. In terms of project setup, what would you need to do to get to this point? Like I said, it's available on NPM, so you can just do npm install gun, then import that either just by including it in a script tag, or if you're using something like Webpack, require in that dependency, and then you can just reference your gun constructor. So var gun equals new gun. You can pass in some options there, which we'll get to, and then you can start using your database at this point. So gun.get references, that grabs a pointer to a node. That node doesn't have to have any data in it yet, just kind of says, hey, reference that, reference that node in the graph. Then you can use .put to put in data to that node. So the data you can put in there can be an object, null, a string, or a Boolean. So that's the params that put accepts. And then there's one other way to put data in, and this is .set, the last method here. What .set does, you need to think about set like a mathematical set, which is an unordered list of unique items. So when you say .set and you pass in a node, say add another item to that list. Or if that item already exists, kind of merge it in. So just keep adding in items to an unordered list of unique items. So that is a really quick tour of the basic Gun API. So
an array of nodes.
You cannot. Yeah, you've got to use, if you want something that's like an array-like, you would use a set.
No. What I'm saying is, with the signature for set, you pass a node an array of nodes.
I don't think so. Yeah, I don't think you can pass in an array of nodes. But I mean, it wouldn't be too hard to add kind of a plugin to Gun to build that capabilities, But yeah.
The last one, does that return the list, the unordered list?
Yes. Yeah. So if you had like var list equals gun.get unordered list, it would contain a reference to that. Yeah. Actually, here, let's use this one. Let me just close these windows out. All right. So the code that I've loaded up here is all right. This is a Vue project. I've commented out the bits that we'll look at later. Mark is smiling because he knows I'm a Vue evangelist. So let me just walk through here. It's got a Webpack and a Babel setup, so you can write some ES6. I've downloaded Gun as a dependency in NPM. We'll talk about why we need this, but I'm going to clear local storage on every page load. And I'm going to import Gun as a dependency, and then here I do my constructor, and I'm just going to set it on the window so I can reference it easily in the console. Right? So that's all the setup I've done so far so that we can do some work on the console. Right? Gun also logs out some of those messages there, but we're just going to ignore them. So let's start creating that graph that we were mentioning with the employees and the projects. So I've grabbed a reference to the Spencer node. Now I'm going to put some data into it. Okay? Name Spencer, occupation, consultant. So the content there will be this. Aaron, yeah.
How do we create this kind of stuff? That just say get and it's not there and makes it? Or
Yep.
Okay.
Yep. It just creates it on the fly if it doesn't exist. Yeah. Good question. Okay.
So you created it? Or?
Nope. It doesn't. It doesn't really care.
Yeah. How would you know it?
So you can do something like check if it already has a value. Here we'll do one actually. Oops. Okay, so Lucy does not yet exist in my graph. So I want to know, does Lucy exist yet? Val is something that retrieves the value of the node. It does this. It's quasi-synchronous and quasi-asynchronous. And what I mean by that is, if it already has the data in memory, it will return it back to you synchronously, and it's blazing fast. If it doesn't have the data in memory, what it will start to do is go looking in the network of connected peers, and that statement will make more sense later in the presentation. It will start go looking for it, and if it finds it before a specified timeout, then it gives it back to you. Okay, so there's another method that we'll look at about retrieving data out of Gun. But so we're basically just saying, do you already have this node in memory here? And Val receives, what's it, a callback. The first parameter it got there, the callback got is the value of that node, which is undefined. The second one is the key, Lucy. So it says Lucy is currently undefined, which means Lucy has no data yet in the graph, and at key Lucy. So that's how you could check, hey, does this have a value yet? But another thing is, like, let's say in the first example here, Spencer, I grabbed a reference to the node Spencer, and then I put data into it. If Spencer already existed, it wouldn't overwrite the node. It would merge the object. So any data that previously existed there would just be merged with the new data that I put in. All right. So let me put some data into Lucy. And Lucy. So now I'm going to go ahead and grab the data out of Spencer just to make sure it's there. Boom. So we use val again to retrieve the data from our graph. Same deal with Lucy. All good. Switch over here to the application view. You can see this is Gun dumping the data, serialized data, into local storage. This is how it kind of achieves offline first functionality. So there's some metadata in there about the nodes and all of that stuff, but basically it's dumping the graph that it has in memory into local storage. Okay. All right, so we're gonna make one more. Kevin. All right, Kevin is going to be a project manager. All right, so now we've got Lucy, Spencer, and Kevin, 3 nodes floating out there, but they've got no relationships to each other or anything else. So let's start creating our employees node. Now, our employees node, we are going to make a set, this unique or unordered list of unique items, and add in our employees to there. So we're just going to call this multiple times. Temp.set Lucy, set Kevin. Clear this out. So let's inspect the value. Console.log. Oops. Let's inspect the value of the employees node. You can see we've got Kevin, Lucy, and Spencer there, but the value in there is not Kevin, right? It doesn't have his name, it doesn't have his occupation. It just has a pointer to Kevin's node. So if we actually want to get the value from Kevin, we can do something like this. We start from the employees node, we reach down, grab Kevin, and then we log out his value. Okay? Or we can do another way to iterate through that unordered list. We can use a method called map, and we can chain on their val. And you see it iterated through, and every time it kind of found a new node in its set, it passes that into val and logs out the value. Yeah.
How is that working? Is that getting an array and iterating through those, or is it making separate calls for each?
The gun internals, you should take a look at the code. It's really trippy, but basically it uses like this pretty complicated chaining event API. So it's not just like retrieving an array and then iterating through those. It's a little more complicated than that. But yeah, it's like a chainable event API. Yeah. Oops. Right. So now we've got our employees node. We've got 3 nodes in there. Let's start creating some projects. First off, let's create the projects node where we'll store our actual projects, and then create some projects here. So here's project 2. We'll do 2 first and count backwards. Project 2 is going to be named project 2. Give it tech because you were inspired by my presentation. It's going to be in view. We'll do another one in React, and we'll just rename some of these. Project 1. All right, so we've got project 1 and we've got project 2. Now again, we're in that same state where these nodes are floating around with no relationships. So let's add them to the project set. To set 1. Now let's add, remember Kevin is our project manager. So we're going to add Kevin in as the project manager to project number 1. .1.get PM .set Kevin. All right. Now, okay, so Kevin is the PM of project 1. And we've got these other employees, but they have no relationships at all to the projects yet. So let's start assigning our employees some projects. So Spencer.get works on .set project 1. So in Spencer's list of projects, we're going to add project 1. And then we're going to, let's say, do the same thing for Lucy. All right, so now we've created projects, we've created employees, and we've kind of been able to draw some associations together between them. So now let's start navigating from our employees and make our way kind of across, traverse those relationships, and retrieve data somewhere down the line in our kind of set of relationships that we've drawn. All right, so let's get Spencer. .get works on, and let's just log out what is in Spencer's works on set. Okay? You can see here it's an object. We expect it to be a set, so that's not going to contain project 1. It'll just reference project 1. Okay? So let's go a little further. .get project 1. log that out. Oops. All right, so there we've grabbed onto project 1, and the value in project 1, notice it has a reference to another node. This is something Gun does. That should be a reference to Kevin. Let's see if that actually works, though. So in our chain, we're starting from employees. We're jumping to Spencer. We're jumping to the project that Spencer works on. We're jumping to a single project. Now we're going to jump to the project manager of the project Spencer works on and see what that is. And let's see. Yes. The project manager is not Kevin. It's actually a set of project managers. So we've got to go one level further and grab Kevin, and boom, there he is. Okay. We'll just do one more level and then stop there. So Kevin's boss, we're going to say Kevin's boss is Lucy. Oops. Okay. Ooh, this is a new error. Oh, I see. I need to get boss and then put Lucy. There we go. All right. So we're going to get Kevin, and then we're going to get Kevin's boss. And we're going to log that out, and we should expect Lucy. So that's the basics of the Gun API. Those are kind of all the core methods minus one, which we'll touch on later. But that's how you would go about creating a graph, drawing relationships between them, and then traversing those relationships and retrieving the data as you go along. So, any questions, Francis?
Is there a way for us to find out if a node is really around? For example, we created a lot of nodes and we forgot which node.
Mm-hmm. Yeah, so you would use that. You would use the .val and check whether or not it's undefined or not. In kind of like the applications I've been working on with Gun, I haven't had an instance where I'm like, does this node exist yet or not? Because usually I'm trying to generate like a unique key for that node. Yeah. Right. Yeah, good point. Yeah, so Francis would just continue to be there sad and alone with no friends. Yeah, I mean, that's the sort of thing that you'd have to, in your application logic, make sure that you're drawing the kind of appropriate relationships. But if later down the line you go looking for node Francis, it's still going to exist, and you could draw the relationships later. So, yeah. Yes, I think so. Well, let me just check. There's some stuff that was removed from the API recently. Yeah, okay, so .back was removed. So I think there is a method somewhere available, like it's in kind of a separate modules that you have to include called back, where you would be able to kind of traverse relationships backwards. Yeah. But what you have to remember too is the relationships are not strictly linear. They can be circular. They can be self-referential. So, our chain here is linear, but that doesn't imply linearity in actual node relationships, because a graph doesn't care about, which directions the nodes go. So going back doesn't mean you're walking like up a relationship tree, because it's more like a mesh than a tree. Yeah.
So in that class, you added the Lucy and boss to the Kevin.
Mm-hmm.
But, and then when the val, you actually get the object. So did that copy the object into as a value for boss? And because you set what it is just in the node?
It didn't copy the value in here. We can actually look at what Kevin's node contains now. So there's boss, and it's just a reference to Lucy. So if we get the value for just Kevin, it's not like a deep get, if you will. It only gets Kevin and that. So if we want to get to Lucy, we've got to kind of specifically say, you know, go grab the node referenced at boss. That.
The difference between a single value, like a put, is a single object.
Right.
A set is a set of objects.
Right.
So if you put and then get got object.
Right.
If you set and get, you've got all those objects, and then you have to further refine it to get
Yeah.
specific. Right?
Yeah.
I was wondering, a while when you were setting up the project, you did employee works on some project, then you did project for the PM, you did project at PM, blah blah blah. So the nodes, are they kind of like singly linked, where you're saying like from the projects you can get who the project manager is, but from the projects you can't get who works on it, you have to get an employee who works on the project. You know what I mean? Like it's only going one way. Is that correct?
Yeah, that's
How would you
correct.
get it, like, both ways?
So then we would have to say proj1 dot get team dot set Spencer, and then dot set Lucy. We would do something like that, so that if you want to navigate kind of the other direction, starting from the projects to get to the team, you would do something like that. And you would examine, you know, what's in the team. From the team, we can get to, you know, them, and maybe this team member's boss, you know, something like that. Joel?
Maybe you talked about this already, but where's all this data stored?
Yes. Can I defer answering that question? Yeah. I saw Aaron and then Arthur.
Yeah. Is there a way to get a list of all currently existing nodes?
Not that I know of using Guns API. Yeah. Yeah.
Some of the keys you're using necessarily would be
Mhm.
Guns.js, box generating.
Yeah. Yeah. Let's try creating. Let's create a Lucy project, and it should not conflict with the Lucy employee. So it is doing some work there to make sure it's not going to create a conflicting node just because you gave it a key named Lucy. And so,
You have two Lucy employees.
yeah, you would have to use something like, I don't know, I've used like email addresses, something that would be unique for that person.
But that doesn't have the concept of sequence number.
Mm-mm. Mm-mm.
Employee to give it.
Right, right. Yeah. Okay, here we go. Okay, so I'm starting from my project set, and I'm going to get a project named Lucy. I'm expecting this to be undefined. Okay, so, but if I do emp.get Lucy .val, we can see that the Lucy employee does exist. The reason for that is because, you know, we're creating a node attached to projects called Lucy. We're not, so it's the like, you know, Lucy project, not the Lucy employee. And so Gun is smart enough to know that like we're looking for something in this set, you know, not something that exists over here. I'm not explaining that concept.
So what if you did gun.get?
Gun.get Lucy is going to grab the employee that I created.
Yes, like
So-
the question is, if you created Lucy in the context of a project and you created a Lucy in the context of employees,
Right.
which one does gun.get?
Neither. It has to. You would have to start from employees and navigate down. So there's the concept of kind of root level nodes, So we created Spencer, Kevin, and Lucy as root level nodes. We created Lucy as a project level node. That makes sense. So you would have to, you can't access a root level node, or sorry, you can't access like kind of a project level node from root. You'd have to go through the project's node. Okay?
It's good to object as the model. You do that. Like you sort of see
Yeah.
the other it's good as the object.
Yeah. Yeah. Right. So it's kind of logically nested. Yeah. It's like logically nested, but like you would access it kind of as if it was logically nested. I should say it that way. Yeah. Mark.
So like, the names make a lot of sense in demo, but in production, when you use something like the .uuid instead of UUID for each employee.
Yeah. Yeah. You totally could do something like that. Yeah. In production, you know, or like there's all sorts of strategies you could use to make sure that they're unique, you know, like concat the timestamp with something, you know, like, but in your application logic itself, you would have to make sure you're not conflicting as you add stuff to a set. Yeah. Yeah, I'm sure.
So, let's say if the project is very big,
Mm-hmm.
someone new came to the project, so he needs to see, the schema. In case of relational data, there's a schema we can show them this is the structure.
Yeah.
But in the middle of this project, is there a way to see how the whole graph looks like?
Right. So that is something you can do. And if you look up like graph visualizers, there's some pretty cool things that you could do. And you could totally build a visualizer for, oh, here's what my graph looks like. And do something that would kind of traverse all of the relationships and then build a visual picture where you could see it. But Gun doesn't really provide that kind of out of the box. Does that answer the question? Yeah.
Everything is in memory, so who designed it, it must come.
Yeah. Right. Cool. Luis?
If you did try to like add another Lucy where it already exists, it wouldn't tell you where. Like if you just tried to add another Lucy to Gun,
Mm-hmm.
it's gonna get Lucy dot put and then gave a name, a different name, it would just override the name.
Yeah.
It's up to you to check.
Mm-hmm. Right. So, yes. I mean, this is like that's akin in a relational database to say like insert name on, you know, primary key 1. You know, of course it's going to overwrite the name. You know, so but it's up to you to check. Oh, I'm not going to do that. In a relational database, though, we also have the concept of just like you're not inserting on a primary key, right? You just insert a new row and it appends it at the end. You don't really have that concept in a graph. Yeah. Cool.
And then you can merge it. Can we show an example of how it merges if you can add some technology?
You say how it would merge? Yeah.
Object of value technology.
Yeah. 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 So if I do this, we've got Lucy's name currently is Lucy, but we're going to replace her name to Charlie, but then add a new something like that. So let's say years experience. And
Just like text equal to word.
say what?
If I write text there, the existing property will equal to word.
Yeah.
So I cannot add a single. Multiple text will develop a different.
Yeah, I think so. I think, yeah. So that sort of, we added some new things that got merged in but changed her name. And I errantly put that there. Okay. All right, I'm going to press us onward because there's a lot of interesting, fun stuff. But at this point, you basically understand the Gun API and how you would go about creating a graph. And I think, as you pointed out, there's like all these sort of cases where how would I handle that in my application logic? And that's something, you know, you kind of have to figure out as you build an application on Gun. Okay. Right, we did that. Offline first. So we talked about how Gun dumps into local storage. That's all fine and dandy. So let's simulate creating a server that it syncs up to. It's going to sync up to the server, then we're going to kill the server, then we're going to make some data changes on our browser, and then bring the server back online. Right? So we're just going to walk through the process that's visually represented here. Right? So to do that, I need my console. All right. Let's clear this out. I'm going to make a directory. I'm going to create a new project. NPM, think about it. We're going to take all the defaults. All right. I'm going to bring in 2 dependencies, Gun and Gun-Mongo. So what Gun does out of the box to kind of have a long-term persistence is it dumps the graph to a file. This is okay until your file is 2 gigabytes, and then it gets really slow and your application is sluggish. So what you can do is plug it into more traditional databases, something like MySQL or MongoDB, and it will dump the graph and retrieve from the graph from a database. So Gun-Mongo is such a thing that dumps into a Mongo database. So we're going to set it up to do that in a bit, and I'll talk about the reason why later. Okay. So I'm going to go about creating a Gun server that can sort of serve as a hub for devices to connect to and sync data to. Just going to write a little bit of Node here. So import Gun as a dependency. We're going to create an HTTP server. And have it listen on port 9000. All right. So just like we did in our browser setup, we're going to say new Gun, except here on the server side, we're going to pass in that HTTP server instance. Gun uses WebSockets to communicate. The WebSocket protocol starts over HTTP. And sends an upgrade request to upgrade to WebSockets. So what this allows Gun to do is attach to a web server in order to process those requests and then serve its data and syncing behavior over WebSockets. And we're going to add just a little bit of sugar on here. Hey, what? Yeah. Is that better? I can do bigger stuff. Sorry. All right. And then we're just going to do this for a little helpful debugging. This will get called whenever something tries to connect to the server. Anybody spot a syntax error? We good? All right. Can even take me half the presentation to exit Vim. Couldn't resist. All right, we're good. And we're going to run this in Node. We get kind of some of the same logging statements. So now this server is listening on localhost port 9000, and it's ready to accept connections. So where did we go here? All right, now let's get this on. Okay, terminals here. Cool. So we still got our reference to Gun here, and we can call .opt. And then pass in the address of the peer that we want to sync to. And just check, nothing has been logged out yet. The reason is Gun has no reason to request any data at this point. So let's redo what we already did in part. There we go. I'm going to put that in. We get our peer connected. Our browser just connected up to our Node server. Let's check out local storage. Boom, there it is. It dumped the graph out. pull up another console. Let's make that bigger. Wait a second. What's the name of my? I'm confused. Where am I? Oh.
You can't go into the directory.
I didn't go into the directory. Anyway, well, that just makes it harder to see. Right here's a file called data.json. So let's print out that file. Oh, now I got to go up. All right. So there is the graph dumped out in a file on my server. So let's go ahead and add some more data here. Actually, sorry. Let's kill the server first. Kill the server. We start getting those irritating WebSocket cannot connect messages. Run.get Lucy.put occupation consultant. So this is going to dump into our local storage here. So there's Lucy, but over here, nothing is written yet. But as soon as we start up our server, that stuff should get synced, and we expect, there it is, there's Lucy, if you can make it out. And Lucy got synced up and written to the server. All right. Mm-hmm. Yeah. How is it happening? Right. It recognizes when it reconnected, and it's going to shoot up the data that's changed. And the gun server is going to say, "Do I have this yet? Oh, I don't have it yet. Here, store it." You know, and then it's gone. Yeah. Yeah. Right. Right. I did, but I didn't reload. I didn't reload my browser when I turned it off and on. But we can actually now. Let's do that. Reload here. Okay. So we've got no value in local storage. So var Spencer equals gun.get Spencer. So at this point, what it's actually going to do is reach up to the server and get the data that we put in from our last kind of session. I'm going to use .on because it's going to run asynchronously. Now that is unexpected. Oh. Wrong console. Oh. Spencer dot console. Do it. Oh. That's what I got to do. Oh, I wasn't connected to the server. That's why. Can't sync if there's no connection. Yeah. It should look just the same, but it gets called a little bit more frequently. Oops, Spencer.on. So on does two things. On will send out a request to say, hey, find this data. Do you have it? Do you have it? Do you have it? Oh, you have it here. Give me the data and send it back to the person requesting it. But it also is kind of a subscription model where it says, if this data changes, send me the updates. So the kind of database will actually tell you, hey, did Spencer change? It did. Here's an update. Yeah. Yeah. It just gets it once. Yeah. So in like real world applications, you're almost always going to use on and never val. Yeah. Oh wait, sorry.
So if you can use
Because, okay, if you had a Spencer and a refresh, you create a node that's called Spencer, and you put different data in it, and then you connect to the server, and then do a val, so you get the local version.
I think you would get the local version and not.
The local version if you use on.
So if you do that, you would first get on, because it's going to check its local data store and say, oh, here, I've got some value. But it's also going to reach out into the network and say, what do you have? And when it gets it from there, it's going to call the callback again. So you would get multiple calls as the peers respond with their data. Yeah.
When you use val, it returns the object and it returns the name that you have sent.
Yeah, the key. Yep.
This on looks like it's returning a bunch of stuff. What is all of that?
Right. So this is it calling that callback multiple times. And let's see. Yeah, this is kind of some gun internal stuff that what you can do is this .off, which says unsubscribe. So that second parameter gives you the option to unsubscribe. Yeah, more or less. I don't know what all of those keys do, but there's the back end.
The one after
Where are you talking?
on that line.
Yeah,
Goal.
right. There's my soul, guys. It's pretty sad. Hey, so it's almost 1 o'clock, and I think we're only supposed to go until 1. I've got some more stuff, and I would like to show it, but I recognize that if you got to go back to work, feel free to leave, and I will not be offended. But if you want to stay, hey, happy to keep you. If that's fine. Okay, cool. So I'm going to do the stuff that is like cool and exciting and real-time data sync. And I'll do that, hopefully try to do that in fairly quick order here. So what we want to be able to do is sync between multiple connected peers. That's kind of where the real fun and exciting stuff happens. Before I presented, I basically wrote this script and I wired up and put it into 2 Docker containers. Those Docker containers run on port 9001 and port 9002 on my local host. Local host 9002 gun. I refer to 9001 as London and 9002 as Sydney, respectively. HTTP, yeah, I'm not sure. Can I move this? I do not. Okay, good catch. HTTP localhost. All right. I'm going to use a database called Gun Demo and a collection called Washington, D.C. All right. Anybody spot a syntax error? All right. So let's see if this runs. It does. So we're good. Let me just show a visual of what I'm building here. I'm going to scroll through a whole bunch of slides. All right. Cool. Basically, this is what I'm attempting to set up or sort of simulate. We've got London, we've got DC, and we've got Sydney. DC is a hub here, and it's connected to London and Sydney, but London and Sydney are not actually connected to one another, right? Okay. So that is what we're simulating. And by putting those kind of just addresses in, same as we would do in the browser, it says connect to those gun servers and sync up with them. So, oops, where did that go? All right, I'm just going to uncomment my view code so you can see the app that I built here, the to-do app. Save that. All right, load this up. This uses essentially the same design as we were using in the console. It's not going to connect to anything, but I built this handy dandy little drop down. When I click on it, it should attempt to connect to that peer. Cool. So each of these is only connecting to one peer. In the browser, you can do the same thing, say peers and pass an array and sync up with multiple of them too. That's totally fine. But I've set this up so each one will just connect to one of those 3 gun servers running. Now, if I've wired everything up correctly, we should get some real-time syncing. Whoops, spelled that wrong. We can click on to-dos and complete them. Yeah, there we go. And delete to-dos. That's a little laggy, but it's okay. Latency. Chalk it up to latency. All right. So, just kind of for like point of reference, to do this sort of real-time work in using something like REST or and kind of any other applications, like you wouldn't imagine that the server that did that is like 25 lines of, like 25 lines of code basically. So it's pretty kind of quick and easy to set up to do that. So let's say that Sydney gets a major power outage and its server goes down. Where's my terminal? So let's just stop that container. Oh shoot, did I lose everything? Oh, here it is. Okay. So this should show up in London, but not Sydney because Sydney is down. All right, sysadmin gets a call, gets on the job, says, you new front-end developers, check this out. Restarts the server. We're back up and running. All right. Now, hopefully. Yeah. Okay, so this is the same thing that I saw when I demoed to Jeff at first. You can see this got sent up, but not all the updates made it over here. But I think if I complete this to do, it will show up. It should have been subscribed. And so I need to figure out, was this a flaw in my application design? Is this a flaw in my kind of application code? Or is this a bug in the way that Gun handles resyncing up? And I'm actually not totally certain which one that is, but something to chase down. But what I would have expected is that Sydney would have retrieved all of those to-dos that were created and resync up the action. So something you can imagine here, though, in the scenario where Sydney was down and we changed a bunch of data that also changed in London and DC, and that's where the need of, well, wait a second, what happens? How do you resolve those conflicts? The other kind of question I mentioned at the beginning, and this is where I will end, the other question is, hey, we just dumped a whole bunch of stuff into local storage. We can't have that hanging around on folks' browsers, right? So how are we going to handle those things? So let me just point at answers to them. and then open up for any last questions. If you're into cryptography, this is Mark Nadal, the creator of Gun. I'll leave that up here. The basic approach is to encrypt everything at point of entry. So all data that would be written in local storage, all data that is transmitted and stored on any server or any device listening would be fully encrypted. And via kind of a combination of passwords and keys and things like that, authorized folks would be able to access it. So we're talking end-to-end encryption, basically. So that's the approach. This is some of the more technical details if you're into stuff like that. The other thing is, so what happens when several users change the same data at roughly the same time, or in the case where they're not able to sync up and later sync, what happens? So the approach is to apply an algorithm for conflict resolution. And here's the kind of key: eventual consistency. When we think of, hey, what is this current state of our data? Like, okay, run a query on the database and say, what is the state of your data right now? For Gun, the calculation is a little different. Let's imagine Elon Musk gets his wishes and we're living on Mars and the latency from Mars is awful. So somebody is using your app and they update something and the update comes to you 30 minutes later while all these other things happened. How does your application handle that? The goal is that the man on Mars and here on Earth would reach eventual consistency. Okay. This is one of those paradigm things that's like mind-bendy, but something to think about in a distributed system like Gun. There's a little video here you can find on Facebook, or YouTube, 55 seconds where Mark quickly explains how the algorithm works, but we'll save that for another time. So that is the end of my presentation. Any?
Maybe I missed it. So when you're syncing, how much are you syncing the entire, all of your nodes with what you're finding remotely, or is it just storing up the changes and syncing that? Like eventually you're sending up and receiving 2 gigs.
Right. So in short, no, you're not going to sync like the entire graph. But what I don't know is what is sent, and that's what I don't know the answer to. But I know it's not the entire graph. I don't know if it's some sort of like like diffing, saying what did I receive and when was the last time I sent updates. I'm not sure how Gun internally is deciding what it sends and what it doesn't. Yeah. But
On that note, on your app, was the date, the timestamp something that you added to the data, or is that built in?
that's a thing built into Gun, and yeah, it uses that in the conflict resolution algorithm. I don't know if it uses it also to decide what to send, but yeah, it has a timestamp in there. So I don't know.
Are there ways for the conflict resolution, like where I can't figure this out, and it'll send you back like user needs to manually resolve, like if it's the same record,
Yeah.
3 different users change it 3 different ways, and then somebody comes offline, like who wins?
Yeah. Yeah. That's a great question and something I've wondered, and I don't fully know the answer to that. It doesn't give you like a kickback and say, I can't do this, manual. But I think that the algorithm would produce a result in that situation. So if that's a result that you want, you'd have to decide. But I think this is the sort of thing at application level, you could kind of figure out a way like, oh, the conflict resolution algorithm is not going to work in this instance because X or Y business rule, that you would have to find a way, to manage that. Yeah. So.
Timestamps is used in JavaScript. Client-side timestamps.
Yeah. Okay. So time also is a really interesting thing, which anybody who has had to deal with like date time and time differences is knows that that can be a headache and be a source of a lot of bugs. So I know it has some intelligent processing and like generating the timestamps. And it's a distributed system, so your server is not going to be on the same time everywhere, because theoretically your server is not a server, but servers. And your browsers obviously can be in who knows how many locations. So there's some sort of intelligent processing of time to make sure that you're not just like, taking one place as the source of truth for time. It has to account for the distributed nature. Yeah.
Since you're part of the community, how many production activities? How many activities in production? Any big names?
I don't think there's any big names using it. And I also don't know how many applications are in production. So the other thing about Gun is right now it's in version 0.8.3. The big goal for this release is to nail down some security stuff. And then in version 0.9, the roadmap is to kind of clean up a whole bunch of bugs and stuff like that, get the documentation really cleaned up, and then do a version 1.0. So it's also a pretty exciting time to be involved, because it's like, you can be involved in the direction of how it's going and how the API is developing, but it's kind of a back of like big companies using this for huge production applications yet. I think it'll be a neat thing in the next couple of years to see what happens as people, stress test it on an enterprise application with whatever, thousands or millions of users, what happens. But it's a fun time to be involved because you get to be involved in that direction. So, yeah.
Just from a logical perspective, let's say, maybe this is like totally a dumb example, but let's say like I've got a bank account online that's using this, and I just like spoof my local data to say I have $1 bajillion, and then I sync up with them. Like, how would they even know that I
Right.
made that falsely?
Yeah. So, there's two concerns there. One is like, if anybody can just write to your database and it's a bank, you've got a problem, right? So your application logic is probably broken. Also, the Bitcoin hack recently, it was Ethereum. Somebody effectively did that and stole like $30 million of Ethereum because of a programming statement. They missed I think it was a method should have been private. It was one keyword missing, and $30 million was stolen out of Ethereum. But that all aside, Gun probably should not be used for banking unless you're doing blockchain. So that's one thing, because of that eventual consistency stuff. Like, you have to know the amount of money in the database at this time. You can't think, well, eventually it might show the right amount, right? That's not possible in banking. But you could build a blockchain application that would do banking in that. So, but the last question of how do you control who updates what, that's the burning question in my mind, and the security thing that needs solved, because role-based access control is a huge thing that's necessary in applications. Who gets to see it, who can write to it, and how do you control that? Some of that is application level logic that you've got to enforce. So. But if they can just access and pull data on client side, how do you enforce it? So that's a big question to answer. We gotta wrap it up. I'm happy to answer questions afterwards. But thank you all for listening, and I appreciate it.